Okay guys, big hello, and yes, we're back. Been a little hard the last few months with this coronavirus garbage, but now things are starting to settle down. We're getting back to normal. Well, we are here in Australia anyway, and we're going to get on with our solar projects. So the first thing we're going to do, and what my channel is about, is saving you money on everything solar, doing it as cheap as we can. So we're going to start off with a solar panel hack. This panel you're looking at here, and I've got shitloads of them floating around the place, is an old rooftop solar panel. Came off a old rooftop solar installation. So what we find now is everyone started a few years back putting up a small system on their roof, finding that there was some benefits in having it, and now upgrading to larger systems and newer panels. And so what we get is a lot of these old excess panels coming off of rooftop solar systems and being discarded, getting sold really cheap. So I bought 5 of these for $100, so there's $20 a panel, and the older panels, these ones are 190 watts each, and they are 36 volts, but we want 12 volts, 36 volts being their maximum working power range, so they will get maximum current at 36 volts or below. Above that, the open voltage is about 45, but the current starts to drop right off after you get to 36 volts, which is going to suit our needs perfectly. So what we're going to do now, what you could do if you wanted to spend the money, is just go and buy yourself an MPPT charge controller, and you could hook this panel up to that charge controller and it would charge your 12 volt battery, no problem at all. You can do it that way. If you want to go cheaper and not spend the $150 odd on a decent charge controller, this is what we're going to do with this panel. We're going to convert this 36 volt panel into 12 volts. So we'll have a look at the panel. Now, these panels that come off rooftop solar are very decent panels, mostly. Far better than the ones you find on eBay. A higher quality, better grade and better performance. And so there's no problem using them. Most of them are 5 to 10 years, 10 years maybe, 5 to 8 years old. They still have a good 15 years left in them at maximum performance, and even after that they don't drop down all that much. So nothing wrong with the panels that come off rooftop solar. People just want to upgrade, put more back into the grid, save more money, and so all these panels just get either destroyed or sold off really cheap. You can find them on, I find these on Facebook Marketplace around my local area, and like I said, 20 bucks a panel for a 190 watt panel, you can't beat it. The only thing is, it's 36 volts and we need 12. So if we have a close look at the panels, you can see that we have a series connection here between 2 rows. So these 2 rows are series connected at the bottom, these 2 rows series connected at the bottom, and these 2 rows are series connected at the bottom. So what we actually have is 12 volts, 12 volts and 12 volts. So if we come up the other end where our box is underneath the panel, which we'll have a look at a little later, we can see here that the last strip on each side has its own separate buzz bar, and that goes down underneath this buzz bar here as well. So there's actually 2 at this point here running along the panel. Now what we want to do is we want to split it here and here. So that's going to give us 3 separate 12 volt panels. And to do that, we're going to well, we'll flip the panel over and we'll show you how we do that. Obviously we're not going to do it on this side. This side's got the glass. Now the two middle rows we don't have to worry about, because once we break it here and here, these two middle rows are series connected down the bottom, so it goes down, across and back up, and our two strips that we need here, our two buzz bars, actually go into the two middle terminals inside the box underneath. So we don't have to worry about picking up on those two because they're already there. So what we want to do is get a marker pen, and we're going to mark our solar panel here and here. That's just so we know where we're going underneath. And of course we'll just get our square, oh sorry about the glare, get our square, draw a line down there and along the bottom, and we'll be grinding from the bottom side. So that's what we want to do, is we want to grind down to this buzz bar here, cut it, and then we can parallel connect to these two in the middle. So we'll be picking up on this one and this one, so say negative and positive, we'll be going to negative and positive here, negative and positive here, once again the same, we'll be going to negative positive here inside the box underneath. So I'll flip the panel over now and we'll have a look what we're going to do there. Okay, so we're on the back side of the panel now. We've flipped our cap off of our box and we've marked where we've got to grind. I'm just going to use a die grinder. You can use a Dremel, whatever you like. And this is just like a sheet of thin film plastic. Underneath this is a thin layer of silicone. So when we grind here, and I'll give you a little tip, if you put a bright light underneath the panel you'll see exactly where you've got to grind. So that might be the way to go, but I just used a marking square, and we now have our mark where we've got to grind away our plastic and silicone layer to reach our first buzz bar, which goes to the first row of cells on each side of the panel. So that's our first mission. Grind down carefully until we reach our buzz bar, first buzz bar. We will then cut that buzz bar, and we're going to peel a bit back this way and this way, and we'll cut this side off, and then we're going to grind through the second layer of white plastic to our second buzz bar, which will give us our second row of cells, and then we'll have a negative and a positive for our two rows of cells, which is our 12 volt link. Inside the box you'll see three diodes. Now a lot of people think these are protection diodes. Not so much. What they are is, because these panels are all series connected, if this panel gets fully shaded, the current from the panels before it can still flow through these diodes and continue on its way, because if we shade a panel without these diodes, current will not flow through it. So the diodes are to allow current to flow in here, or looking at the way these diodes are, the current flows in here, through here and out here. If this panel becomes fully shaded and it's in a series connected situation. 12 volt panel, you'll only see one of these, and that's all it needs because it's 12 volts, and it's for the same thing. They're not a protection diode as such. They allow the current to continue to flow should this panel become shaded. So the first thing we're going to do is we're going to just lever those diodes out like such. They're only pushed in, they're not glued or soldered or anything like that. And you can keep these for other projects because these are nice heavy duty diodes, should you want to use them for something else. And there you go. And I'm pretty sure they're Scotch key diodes, so as we don't have a very large voltage drop through them. Alright, so on with the grinding. So we're going to, like I said, carefully grind much of this plastic away, and you'll see the buzz bar come up if you're nice and gentle and don't dig straight through it. Perhaps just grind down until you get rid of the white and most of the silicon, and then use a sharp knife to scrape the rest of the silicon off. I'll go ahead and do that, and we'll come back and have a look when I've gotten down to the first buzz bar, which, like I said, is the buzz bar, the two outer strips or two outer rows of cells, and that'll give us our spot to start from. Okay, so we've ground down to our first buzz bar. You'll see here that it's copper, they're a tin coated copper buzz bar, and I just gently go through the tin until I reach the copper, and that's good enough. So what I'm going to do now is get a sharp knife, and we're going to cut through that buzz bar like so, get underneath it, flip it up, and we just take a pair of cutters or pliers and we simply roll it back like this. Don't squeeze too hard, you cut it in half until we end up with a nice strip like that hanging out. Like I said, they're fairly thick, so no problem there. This one here we're going to do the same, just lift it up, tear that back a bit like so, and then we're going to cut that bit off to get it out of the way. Now you see we have another layer of white. Now underneath this is the second buzz bar we need, which is our second row of cells. So we're going to do the same again, grind down till we get to that, and then lift it up. So I'm going to go ahead and do the other side as well, which we can see over there. I've also ground down, so that's the same deal. Just cut through it like yo. Don't push too hard and go through the bottom and cut through the one underneath. Not that it really matters, but just a good practice not to. Get that one up, do the same, peel that back an inch or two. This one here, which is now obsolete, we just peel back a bit, cut off like so, and get it out of the road. And once again we just grind down till we hit our second buzz bar. So I'll go ahead and do that, and we'll come back and have a look when we're finished. Okay, so we're all done. So you can see we have 1 and 2 pins. That first pin is your first row of cells, and that second pin is the second row of cells. And to get the polarity, we just grab our multimeter on DC volts. Ambient light on the panel will be enough to tell you which polarity is what. We simply hook our multimeter on there. You can see we've got minus 7.82 volts. Now remember, we're only dealing with ambient light here, so the voltage is going to be very low. We're inside the workshop, out of the sun, and it's just the light bouncing off the floor at the moment. So that's polarity correct. All we do now is get a black marker, and we can write negative, positive, and we do the same on the other side. And as this side was outside negative, this one over here should be outside positive. Sorry about the hand camera work, I'm trying to watch through the camera and watch what I'm doing at the same time. And so we're correct, and then we can mark positive, negative. Now the last 2 row of cells, the middle 2 rows, are going to be these middle pins here. And if we put our multimeter on there, you can see once again 7.6 volts. So that is polarity correct, so we'll write positive and negative. So then all we do is parallel all 3 up. So we run a wire, solder a wire onto here. This solders very well, of course. So our negative wire will go from there to this negative, and the other negative one here, the inside one, will go from here to this negative, and then that pin then becomes your output, which will run wires back in here. So that'll be your negative side. Same for the positive. Solder a wire from there to there on positive, and from this one to positive. So that parallel connects our 3 12-volt cells. I'll go ahead and do that. We'll come back and have a look when it's done, and then what we're going to do is wait for the sun to come up. And of course, when we want the sun today, it's overcast, very overcast, so we're not going to get the maximum performance, but we will see that we now have what is called a 12-volt cell. The open voltage is going to be around 15 volts, which also saves us a little more money, because at the peak voltage of 15 volts we will not need a voltage regulator. We can put these wires here straight onto our 12-volt battery. It will charge with high current right up to about 12.7, 13 volts. The current will start to drop off, and once the battery gets to about 14 volts, it'll be a very low current, which means we have a nice trickle charge continuously going into our battery. So we also eliminate the cost of a voltage regulator, because in most vehicles your battery will charge up to between 14.4 and 14.6 volts from the alternator. So this is another reason it's great to do this, because not only do we save money on buying decent solar panels, far better than the ones you get on eBay, we also eliminate the need for a voltage regulator. And we'll get into that later on this video once it's all wired up and ready to go. So we'll be back once I've wired her up. Okay, so we're all done. The positive from this side, which is the red wire, goes to the positive terminal in the middle. Positive from that side to the positive terminal in the middle. Same with the negatives from each side. And then we just put our big cable on those same terminals. So this wire here, 1.5 or 2 mil is quite fine, because there's only 5 amps per side and 5 amps in the middle, for a total of 15 amps peak. And then of course we use our thicker cable to come out, and that's our solar panel done. All we do now is take some silicon, and we go ahead and silicon up all our work here, making sure to get it all so it's all sealed once again. Same on this side, and we'll get in there with our fingers and spread it all around, make sure it's all sealed properly in a minute. And of course you drill a hole in the back of this plastic box for your cables to run through. And we also get in there with a boogie and give it a good squirt, seal all that up as well. And we simply put our cover back on, and we've now converted this 36-volt panel into a 12-volt panel to give us 15 amps. It's quite nice. So a cheap way of going about it. These are good quality panels, normally the ones that come off rooftop solar. Like I said, far better than the old cheapos that last a couple of years from eBay, and in this case far cheaper. These panels are widely available. just head on down to one of your solar installer shops. I'm sure they'll have a heap floating around that they don't really want anymore, and you'll get them really cheap. And all up, if I was to do this project without the filming and that, it would take me about half an hour. So I'm happy to spend half an hour and pay only 20 bucks for a 12 volt panel. What we're going to do now is we'll take it outside and get some kind of load on it and see how we go. Make sure you get all the polarities correct, otherwise you're going to have a dud panel, good for nothing. Alright, we'll see you outside when the sun comes up. Okay, so here's our setup. We got our solar panel we modified, a dual purpose deep cycle battery, and I've got the big 80 litre Waco plugged into it. Been up and running for an hour now. It's only just switched off because it's got down to temperature, which you probably can't see, but it's -3 degrees is what I got it set at. Now, a big shout out to Waco. This fridge is an older one, 80 litre, but it is that efficient. It's a bit hard to believe actually. This old girl still goes as good as the day we bought it. So big thumbs up from Waco, eh? Or for Waco. No, they don't sponsor me. Okay, the battery we're using here is a dual purpose deep cycle silver alloy battery, and this is a 105 amp hour one, but unlike a normal deep cycle, you'll also see we get 800 cold cranking amps from it if required. The panel we just modified, of course, the only day we want some sunshine, and it's shit overcast, but nonetheless the panel has been keeping up with the fridge at the moment. So if you can see that, putting in 1.25 amps at 13 volts. We did get a break in the sun at 12.8 volts when the battery was at 12.8 volts. We got a break in the sun that went up to 11.5 amps. So working a treat. Also in open sunlight, I disconnected the lead, and our open voltage from the cell was 14.2 volts. That's the maximum it can put out in clean sunlight, which is exactly what we want. No need for a regulator, because your batteries will normally charge between 14.2 and 14.6 volts in your vehicle. Unless you're going pure deep cycle, 13.8 volts is all you want. So if you were using a pure deep cycle battery, you can chuck one of those El Cheapo $14 eBay regulators on it and you're good to go. But for my purpose, I use these batteries and normal starter batteries, and 14.2 volts is spot on. So if only the sun had come out, we could see that shoot up, but that fridge, like I said, has been going an hour now and the battery's still holding at 13 volts, so no problem there at all. Our panel works exactly the way we wanted it to work. So there you go, 20 bucks and half an hour's work, and we've got a good 12 volt panel where we don't need a voltage regulator. Just hook it straight up to your battery and leave it at that. Thanks for watching, guys. In our next video we're going to be looking at batteries, deep cycle, dual purpose, and your standard motor vehicle starter batteries. I'm not going to touch lithium ion as far as I'm concerned. They're not worth the money. If weight is an issue for you, then yeah, you can spend your $700 to $800 and get yourself a lithium ion, but we'll have a look in my next video. We'll go through the batteries and we'll get some truth between deep cycle, dual purpose and standard starter batteries. Thanks for watching, see you next video.